Find the mean and median of this data set. Remember, for the mean, we're going to add all these values together and divide by how many values are in the list. That is for the mean. For the median, we have to put them in order first. So let's find our lowest value, which is a 4. And there are 2 of them. Then I see a 6, 7, an 8, 3 9s, 2 10s, an 11, 2 12s, 13, 2 14s, 2 16s, and 2 18s. You are going to find the middle of the list now that it's in order to find the median. You can cross off 1 from each side until you find out which number is in the middle. For this digital lesson, you can either follow along in the video or you can open up your computer and log into Great Minds. It says describe the shape of this data distribution. This one extends far in the left direction, which would mean that it is skewed left. Then it says toggle between the following options. Which better represents a typical value, mean or median? There is the mean and there is the median. It looks like the median does a better job getting towards this cluster. Describe the shape of this distribution. This one has a peak in the middle and falls on both sides, so this one is approximately symmetric. Here is the mean and the median. Then which of those better represents a typical value? Well, they both do. Because they are both near that main chunk of the data. This one extends far in the right direction, so this one would be skewed to the right. The median is closer to this large chunk than the mean, so we would say the median is a better representation. Move any blue data value to 50. What happens to the mean and median? Why do you think this happens? If I move the dot to 50, the mean changed, but the median did not. And why do you think this happens? Well, with the mean, by changing one value, you change the sum, which is used to find the mean. We add them all up and divide by how many. So changing the value changes the sum, which impacts the mean. But it does not impact the median because it's still a point that is on the right side of the median line. It was already on the right and it's still on the right. So by moving this data value, it's still on the right side of the median. So the same number of points are to the right of the median, which does not impact where it is. Move the data values to create a new distribution so that the mean is the same, but the median decreases. Describe your strategy. Let's see, if I move this here, then I'd need to move one of these higher to make the mean match, but then the median's the same again. What if we moved these ones up? So my medians are different and my means are the same. Let's demonstrate that again. I'm going to move one of these points to the other side so that the median changes. My goal is to make the median smaller, so I need to move a bigger point down, but then I need to increase the mean, so I need to move one of these that is on the right further to the right. So that the mean stays the same, but the median is lower. Move the data values to create a new distribution so the median is the same and the mean decreases by at least 5. So it needs to be down to 19.13. 24 minus 5 would be 19. So the median needs to stay the same, but the mean decreases. So we want the median to stay the same, so we're going to leave all the points on the left still on the left side, but we need to decrease the mean by moving them farther down. Which measure is more affected by changes in data values and extreme values, the mean or the median? Explain. The mean is more impacted by extreme values. because the middle point is still in the same location for the median, but the extreme values make the sum a lot higher or a lot lower. This data distribution shows the distances that a company's employees drive to work. Toggle between the distribution displayed in a histogram and a dot plot and a box plot. What is the shape of the distribution? Here in the histogram, it appears to be approximately symmetric. Here's the dot plot and the box plot. The distance from the median to the minimum and the median to the maximum are pretty similar. The dot plot appears to be pretty symmetric, as well as the histogram. It says, explain why both the mean and median are in about the same location. Well, since it's symmetric, or approximately symmetric, the balancing point is going to be similar in location to wherever the middle value is. This data distribution shows the salaries of players on a professional basketball team. Toggle between the distribution displayed in the histogram, dot plot, and box plot. This one appears to be skewed, and you can see from the box plot that it is going to be skewed to the right because that whisker is a lot longer on the right-hand side. Explain why the mean is greater than the median. The mean is greater than the median because it is skewed right. The extreme value pull the balancing point, which we call the mean, toward the right side. This data distribution shows retirement ages for a group of people. Toggle between the distribution displayed in the histogram, dot plot, and box plot. This one is also skewed, but this time it is skewed to the left. Notice now that the mean is to the left of the median. In the last one, when it was skewed right, the mean was towards the right side of the median. When it skewed left, the mean fell to the left of the median. So the mean is less than the median because the distribution is skewed to the left. Less to the left. A histogram summarizes the number of languages spoken by each person in a group of 100. Predict what the data distribution would look like? Well, there's a group of 100 people. Most people only speak one language, but some people speak two, and even less speak 3 or 4. But we needed to add up to 100, so let's see what we have so far. Let's do 55 plus 30 would be 85. So then it can't be 16. Let's do 10. Makes 95. And then if we add 5 to 95, that gives us 100 people. What is the shape of the distribution? Why do you think the distribution of the number of languages spoken might have this shape? This is skewed right. It extends farther off into the right-hand side, and most of the data is on the left. I think this is skewed because more people typically only speak one language. It is uncommon for people to speak 4 languages, especially where we live. Show the approximate location of the mean and median by moving the triangle and the vertical line. Choose a measure to describe a typical number of languages spoken. Well, since there's 100 people, the median would be in between 50 of them. So if there's 60 in this column or in this bar, we need to place the median somewhere inside that interval as well. It is skewed right. And what we know from the previous problems is when it is skewed right, the extreme values pull that mean slightly to the right of the median. So choose a measure to describe the typical number of languages spoken. I would say that the typical would be better off using the median than the mean. Well, if we were to interpret this, we would say that typical people speak 1.4 languages, which doesn't really make sense in this context, but we could say that they typically speak between 1 and 2 languages. You may also describe this as somebody who speaks one language fluently and maybe has the other language they don't speak fluently. This histogram summarizes the height of each person in a group of 100. Predict what the distribution would look like. Well, I think most people are going to be average, so I'm going to place those high in the middle. And then we'll have some people who are shorter, some people who are taller. Let's see, 20 plus 40 is 60, 75. I need 25 more people. So we're going to go 60, 75, 75 plus 8 puts us at 83. Let's add some over here. 83 plus 9 puts us at 92. So we need 8 more. 5 and 3 make 8. So I was correct in thinking that the middle would be the highest and we decrease as we go, but I didn't get them exactly. It says, what is the shape of this distribution and why do you think the distribution this height might have this shape? This one is approximately symmetric. And the reason I think it has this shape is because most people are around a typical height. And we will have some people who are shorter and some people who are taller. Approximate the median and the mean. Since it's approximately symmetric, they should be similar in location. Maybe not exact, but they should be pretty close. Both of them describe this well, but with the symmetric, I might go with the mean. And it says interpret what it is in the context. A typical person would have a height of approximately 155 centimeters. And that is the end of lesson 20. Check back for the next couple of lessons for the end of the module.